Okay, welcome to another video code review. This week we'll be looking at a PR from our contributor Michael Riskala. This is PR 1564, and this implements a CS+20 feature called sync stream. This is a new header, and it adds a new kind of IO stream. The idea is that multiple threads can simultaneously write to basic OSync stream and avoid data races and avoid annoying things like characters being interleaved. Because even if you avoid data races, there's nothing preventing an output stream for, just picking one character or a few characters from threads in an alternating fashion, and that would lead to unreadable output. So this mixes sort of multi-threading, mutexes and locks and IO streams. So this should be interesting to look at. Here I've brought up the PR. As usual, the PR is linked to our tracking issue in GitHub, which lists all the papers. In this case, there was one patch paper added for OSync stream manipulators, and then a few LWG issue resolutions that have patched things, and a feature test macro. So I've loaded those papers in case we need to look at them. I've got the latest CS+ working draft 4878. And let's just start going through the code and see what we can find. Okay, so this is adding a new header, one of three remaining headers we need. So we've got some common files to add. It's also adding separately compiled code, which for the STL brings along its own set of concerns because separately compiled code is a headache in many ways. So whenever we add a new file, there's a sort of set of process that we need to follow. That's documented in our wiki. I used to call this hackthesefiles.txt. There's now a wiki page, files to edit when adding or removing files. So I'm going to double check that these are all being updated because right now we don't really have automation to make sure that these are all modified simultaneously, and it's pretty easy to forget. So let's see. CMake_list_text is adding the new header and a new source file. So that's what we need to look out for. So I'm going to just minimize everything right now. Okay, so CMake_list_text, we've got that, headers and sources. So there should be an edit to our internal build system under the MS build tree. I do not see that here. And of course, because MS build is Microsoft internal, our contributors don't have any visibility into that. I wish we didn't have to deal with MS build, but I will need to add a to-do where we want to do that, sources. So in the source file, I'll comment here that we will need, and we can do this when we port this internally, because anything beyond the bare minimum of complexity often needs special attention. Okay, so we will need to edit this. We'll need to update or another file in the MS build tree for the Microsoft internal build. Okay, looks good. Every day brings us closer to eliminating MS build, hopefully. Next, MSVC all public headers. This is something that is for test convenience, so we can just include everything. It's not ever meant to be used for production code, although I suspect some people doing programming challenges have discovered this header. So this should be all public headers. Indeed, SyncStream is a public header, so should be mentioned, and it is being updated, so that's good. We got SyncStream here. That is in sorted order, as claim format will do, so that's good. I guess I can check CMake_list_text off as well. We got the header, we got the source file. The source file, let me see what the source file is doing. Okay, so this source file is being added to our import lib. So one of the interesting things about the STL is we got so many different ways to separately compile the code. We got the DLL, which is msvcp140.dll. We've got the static lib, libcpmt.lib. And then we have an import lib that is tied to the DLL. Now, import lib is just sort of a convention. There's nothing actually stopping an import lib from containing object files like a static lib. It's unusual, but a few libraries do it. The STL is one of them. And we have increasingly injected object files into the import lib, which effectively statically links them. This allows us to add code without adding exports to the DLL, which currently we avoid due to this obscure ABI binary compatibility thing. So this is being put into the import lib, which we have experience with doing with file system and shared mutex and a few other things. Okay, so that's sorted order. That's good. Okay, so sync list text is good. Let's go back to the hack these files list. We now have a new file that is beginning to be picked up, header units.json for standard library header units. This is for headers. So sync stream definitely is there. I believe a contributor noticed this. Yes, sync stream is now being added. That's very good. And actually, nothing sorts this. Let's make sure. Yep, sync stream comes before system error. Excellent. We have a test include each header alone. This makes sure that we don't use things like, pair or whatever without including the necessary headers internally. Very easy to mess up if you don't have an include each header alone test. This is applicable, I would say, to many libraries. So where is that? Here it is. Include each header alone matrix. Sync stream, again, in sorted order. That looks good. Doesn't need any special macros. Okay. Then we need coverage in the standard library header units test that we just added. This lists all the headers in two different ways for our two test harnesses and the source file. And this is indeed a standard public header. So let's check that. Yep, we got that here. Custom format, now uncommon sync stream. Perfect. Custom build, uncommon sync stream. And the test should use it. So uncommon import sync stream. There is a failure when compiling in static debug, so I'll need to investigate this, but let's see whether this looks plausible. I haven't actually read the standard proposal recently, so I'll be working from memory here. Instead of printing not yet implemented, we're going to construct a sync buff from nullputter, assert that grep is nullputter, assert that the allocator is equal to allocator care. This basically checks the type. This is a using namespace stood test, so the stood qualification is unnecessary. std is already using namespace stood. Yeah, when you work on the standard library all day, having to repeat stood : is very obnoxious. Okay. Of course, we do have some tests that use explicit qualification when that's interesting to test, like the tests that are looking for the standard library user-defined literals. We test that we can drag them in with the right using directives. So we don't want the whole test to using namespace stood. Assert that emit is false. Okay, so there's an interesting bug to test there. I'll leave that comment open. Oh, sync stream sync stir, construct from cout. Let's print testing standard library header unit. So this is derived from the OStream test above. That looks good. And then assert get wrap to cout read buff. Okay. So this test looks good. If only it would pass. So we'll need to investigate why, but that looks good for now. Those are all the GitHub repo edits. Then we're going to need to do a batch of internal edits when we port this over. Let's see, I'm currently thinking, do I need to add a reminder? I will add a reminder to here. Yes. Okay. Note to self. We'll need to follow blah. We'll need to apply the SVC internal edits listed in blah when porting this PR, mirroring this PR. Apply MSV center edits listed in. Okay, great. Yeah, we've been trying to increasingly drive our work with checklists rather than relying on humans to remember, oh, when we do X, we need to trigger Y and Z, because that is so easy to forget. And so this ensures we never forget to update setup, we never forget to add test coverage and so forth, because discovering that sort of bit rot and fixing it up later is annoying. Okay, so that's good. And then we've already done the edits in the VS repository for all C++20 extensionless headers. So the IDE is already going to know that sync stream is C++, which otherwise it won't detect because it doesn't have any sort of extension. When CS+23 rolls around, we will need to begin updating this. I think they just added a stack trace header. But for 20, we had just added everything because we knew what headers were coming. And it's not problematic to teach the IDE to recognize certain headers of CS+, even if they don't exist yet. Okay, so that's looking good. We can close this now. Let us continue reviewing the fairly simple file. So we've got a feature test macro test. We've got the actual test being added. Okay, we are adding test file there, and then another one for the manipulators. Let's make sure that these paper numbers match. I've found many typos and digit transpositions in paper numbers. Those all look good. Okay, so test lists. This is a file that is not actually listed in files to hack because it's for when you add a test. We need the list tests here, otherwise the internal test harness won't run them. So that's good. That's in sorted order. Same. Let's double check. Because nothing is verifying this. These are actually the exact spellings. That looks good. That looks good. Great. So test list is great. Let's just do a quick scan over the env list, which contain the compiler configurations. Here I'm just basically checking that we've got the copyright license banner and that we've got a reasonable set of compiler configurations. We have a bunch of matrices, we call them. So copyright license, we're going to use the usual latest matrix for CS+ latest, CS+20. So that is good. Okay. And same for this one, copyright license, usual latest matrix, looks good. Okay. Let's zoom up to YVAL's core, which is the STL central internal header. So we are going to have comments about the new features we're implementing. This is our sort of internal list of features we support, and then the feature test macros. Okay, so let's see. We're going to mention the paper here. And this is in the CS+20 list. That's good. Meaning I have a convention where I like to clean up the paper titles to make them simpler. In this case, I've recommended just calling this paper sync stream. Even though the original title was C++ synchronized buffered O stream. So I will mention this here. At some point, people may convince me to stop being so picky about the titles that we use, but for now, I will comment this here. We conventionally clean up the paper titles to make them simpler and consistent. So the papers listed here should match, what was this issue? Issue number 3, very low number. The titles in issue number 3. Say stylistic nitpick. Okay, that looks good. And ditto for the other one, where I think I felt that async stream manipulators was just a simpler way to capture this rather than manipulators for CS+ synchronized buffered OStream. Yeah. Okay. So that's cosmetic. For the feature test macros, let's make sure whenever I see something being added to a list, I like to make sure that I'm actually in the region that I think I am, even though since I saw span there, I know that I'm in 20. Yep, we're in the 20 region. So we got sync buff. This is in sorted order between ST and TH. Yep. Let's make sure that this is the right value. These are the values mandated by the standard and SD6, which is if you look for probably the easiest way to find it, if you look for was it SD feature test is what they're now trying to call it because numbering them is weird. There's a page on isocpp.org. This is a living document that reflects the state of all feature test macros in the core language and standard library. This contains sort of rationale, duplicates the content in the standard, which specifies the feature test macros, except that it contains historical values when a feature test macro has been revised in place, and also explains which feature or paper it corresponds to. So for example, CPP concepts has been updated in place a couple times as they have patched it with additional papers. Const expr has been enhanced a zillion times, like when const expr was extended to not require single line functions, that increased the feature test macro. So if there's ever any question about, hey, you know, what does this feature test macro number mean? Standing document feature test, or SD6 as it was previously known, is the one to consult. So the correct value is 2018-3 CPP lib sync buff. Yep, this is short enough that I can just verify that it's spelled correctly. If I were paranoid, I would actually copy paste and then search to make sure we're not introducing any spelling errors. So that looks awesome. This is plain format aligning everything. Plain format is awesome. Okay, let's check the feature test macro test, which is largely like duplicating the functionality of YVAL's core H, but it is useful to have a sort of second opinion that the feature test macro is properly expanding. This was more useful when I covered the compiler, but we split that out into the compiler internal test harness. So in 20 mode, everything here, I'm just I quickly check that all of these have been searched and replaced. So they all mention sync buff. They all mention the value. In the past, I have caught a couple cases where the search and replace was incomplete and like an old value was mentioned in a string or something. So that all looks good. It's 2018-3, and that this block of preprocessed stuff is in sorted order, which it is not. Here, ST, SY, and ST, so this is out of order. Easy to miss because this test contains all the feature test macros and uniformly sorted and not grouped by standard level, whereas I suspect it's being put in this place because in YVAL's core it probably comes after one of these. Let's see. Yeah, in YVAL's core, because it's grouped by language level, you got starts with, ends with, immediately followed by sync buff, and then the next one in CS+20 is three-way comparison. But here, putting it after starts with, ends with is insufficient because there's this string of UDLs from CS+14. So I will add a comment that this should be moved so that it occurs in sorted order within this file. Note that this isn't grouped by standard edition, standard version maybe, unlike YVAL's core H. Okay, hopefully that's clear enough. Yeah. Okay, purely cosmetic, but I do like sorted order. Okay, so what are we down to? I've done the easy stuff. We've got the actual test code here. we've got the separately compiled source file, and we've got the declarations in iOS forward, and then the header. Okay, so let's see. Let's start looking at iOS forward maybe. And let's start matching this up against the standard users voted in. That go down to the wording. Okay. So this lists a new header, of course. Okay, so iOS forward. This is the first one we're looking at. We've got basic sync buff templated on character type, traits and allocated with defaults. We've got aliases for the narrow and wide, sync buff and wsync buff, same for osync stream, and that's it for iOS forward. Okay. So let's look at iOS forward here. Okay, pound if underscore HESCX620. We always want to make sure we use if and not ifdef for this macro due to our conventions. Template on LM and traits, make sure they're all ugly. Defaulting care traits LM. So here, there's a forward declaration of basic sync buff impl. This is interesting because it's internal. I don't expect to see this here. I'm going to need to search and see why this is here. But we do have the standard declarations for basic sync buff and basic osync stream. That looks good. And then we have the narrow aliases using sync buff and osync stream for care. Yep. And then if 20, we have the wide aliases, the wosync stream. Yep, that looks good. Do we need these? We don't need accursed unsigned short type desk for this new stuff. This will hopefully disappear and be next. Okay, so that's good. So why does basic sync buff impl need to be forward declared in iOS forward? Is something using it? So usages within, I'm going to collapse this for a bit. Sync stream and osync stream, presumably. So who's using this? Where's the definition? Good, only 10 occurrences. Okay, so this is, I remember Michael asking about the technique here. This was actually related to the manipulators paper that was voted in. So we need to, in OStream, which doesn't know anything about osync stream, which is like derived stuff. This emit on flush function needs to detect, oh, are you actually a basic osync stream? Except that it doesn't know what allocator there might be. So there needs to be a base class that type erases the allocator that this can then dynamic cast to. This is actually mentioned somewhere in the manipulators. Yeah, it's actually a non-normative note. To work around the issue that the allocator template argument cannot be deduced, implementations can introduce an intermediate base class to basic osync buff that manages its emit on sync flag. So that's what that's doing. So that means that this forward declaration in iOS forward is necessary for STL internal purposes. So that looks wonderful. Good. So now let's look at OStream. That looks like this paper. Here I really should be consulting the working paper where all this stuff was applied. Here I'll just get an idea of what was added. So in OStream, these manipulators are emit on flush, no emit on flush, and flush emit. And then definitions of them. And sync stream is now mandated to include OStream, and that's it. Let's just check that before I look at the definitions here. Sync stream definitely includes OStream, so that's mandated, so that's great. Okay, so just to be safe, although I don't think anything has been patched here, there were actually, yeah, there were patches made, I think, to the core paper, not or to the original paper, not to the manipulators one. But let's look at what was this ostream.manip. Okay, wait, 4,000 milliseconds for this to search. Okay, so we need these three here. Let's embiggen this. Okay, so emit on flush. If OS rebuff is a sync buff through that dynamic cast, Call that buff. Call set emit on sync true, otherwise no effect, return OS. Okay, so that one's simple. Let's look at this definition. Okay, so if we're in CS+20 mode, we also need a dynamic cast. So we need RTTI. Usually the STL does not actually care about RTTI, but in the few cases where we do, we have in a few years ago started allowing the STL to tolerate the lack of RTTI when somebody disables that. So we'll let almost all the STL be used except for the necessary parts. So here, if def underscore CVP RTTI will detect that. I think that's what we use on that. I don't have an enlistment here or clone. We don't, I think, check a feature test macro for this. CPRTTI is what we use elsewhere. Because we need dynamic cast for all these three. And then otherwise, this PR is deleting them with the comment requires GR. That is what we do elsewhere, so that looks perfect. Okay, so we're gonna template on element traits. Here's your emit on flush. It's not const X for anything. This has side effects, so we definitely don't mark any of these as no discard. Takes Oster. Yep, it can't be strengthened to no except, I think. So we're going to try to dynamic cast. We store that in an auto sync buff putter. This could be top level const, but it's not critical. It's a pretty small function. I won't comment here. In longer functions, we like to apply const everywhere. We're not 100% disciplined about it, especially in older code. Here, I won't recommend it. Dynamic. It actually occurs, it occurs 3 times. And if I'm going to comment, I'm like mentally torn here. If I'm going to comment about like stylistic things like the paper titles, const actually has a little bit more meaning. I'll mention it. The 3 occurrences of sync buff putter. It's always a challenge. Like, okay, like how much, how many nitpicky comments are too much versus communicating our code-based conventions and writing really high-quality code every time. In these functions could be top-level const. We prefer to mark local variables as const whenever possible in order to avoid unintentional modifications, and to make modified variables stand out more. A long-running goal. Okay. Yep. Yeah, none of these are modified. Okay. I like the use of auto there. We have a convention that when we're going to cast, whether static cast or dynamic cast, why repeat the type? Just use auto. So that's perfect. So it's going to try to dynamic cast up to basic sync buff impl. If we can get that pointer. So if it's not null, then call set emit on sync true, like the standard says. Otherwise, do nothing. Always return Oster. Perfect. So let's see. No emit on flush. Is this basically the same with false? It is. And returns OS. So same pattern. Call it with false. Perfect. And then flush emit. Oh, I can be looking at the working draft. Calls OS flush. Then if it is a basic sync buff, call buff emit. Okay, so we always got to call flush. Turns OS. Okay, so flush emit, always call dot flush. Try to cast up. Okay, so this is repeating a bit of code, presumably what the standard implementation of emit does. If we can't call underscore do emit, then set the bad bit. Okay, and then return Oster. So let me double check that emit, yeah, does do emit and then bad bit, which is not, presumably not available on the basic sync buff impl. So let's check that. Be called it do emit. Got a virtual that returns emit. Okay, so this is a virtual on the base class that calls emit on the derived class. Okay, so that's good. Where's that? Okay, emit is a big function. Okay, so it does a bunch of logic, but it doesn't itself set bad bit. Okay, so I'm confused as to what's happening here because this override and do emit just calls emit. And then the standard says that flush emit should just call emit. So I don't understand why flush emit has to manually set bad bit. If bad bit needs to be set, shouldn't it be set in emit itself? Why do we need a separate layer applying it only here on the oster? I am either confused, which could easily be the case because I'm not an IOStream expert, despite working on this stuff for a decade. It is definitely worth a comment. Okay, how do I express this? I'm unsure as to why flush emit needs to set bad bit on error. The standard, let's get the citation here. OStream manip 12. Simply, the standard says we have a auto links, which is awesome. N4878, I'm doing the right thing. It was OStream manip. I really should be copy pasting to avoid typos, but I'll try that. Okay, 12. I'll chop out all that unnecessary context. Off emit. No, we should put that. Okay. And then below or in osync stream, I could quote it by getting the absolute link, but here I'll just find, where was it? Do emit. It's down here. Yeah. Or sync stream. Do emit directly calls emit. Be highlighting. So if bad bit should be set, I would expect it to be set within that happens on the oster, not the buff. Maybe there's maybe what I'm missing is wording that these are formatted functions. These are designated addressable functions. Okay, so I could be missing wording somewhere. Ah, I should have scrolled up. Here it is. Each unformatted output function constructs a sentry. These are, oh no, sorry, I scrolled too far. These are just standard manipulators. Okay, never mind. Okay, so now I'm confused again as to why there's a bad bit. Okay, so I'm going to chop this because I see that the buff layer is different than the stream layer, and the stream's got the bad bit stuff. You set bad bit on error directly calls emit. Is there some standardies I'm missing? Okay, pose it as a question. I'm unsure as to why flush emit needs to set bad bit on error. The standard says W1 and 4878, OStream emit 12, calls buff emit, and OSync stream do emit directly calls emit. Is there some standardies I'm missing? Okay. Okay. Otherwise, if we don't have RTTI, then delete all these. There is no reason to name parameters deleted functions. Perfect. Okay, great attention to detail there. So this header looks good. Okay, now on to the actual header. Let's take a look at this. And we got all the manipulators done, so that's one paper down. Okay. And I'm just gonna look at what was voted in. So we've got the new header, we've got the IOS4 that we checked, the header sync stream. I'll just look at the standard for that. Bunch new wording, which has been patched by LWG issues. This got changed, so we've got the standard names. That's good. Okay, so let's take a look at the standard here. Let's go look at the list of bookmarks, input output, synchronized output streams. Here we go. Okay, so this header, we already checked that it includes OStream. It defines the basic sync buff. Yeah, and this is OStream is going to drag in as for it, I believe. So we've already got all these type defs. That's good. So it's going to define the sync buff and the OSync stream. Only 2 classes. How hard could it be? Okay, so let's check. We've got the header. This is indeed a standard header, immediately followed by our license banner. Awesome. We've got our usual incantations. So I'm working from memory here because I've seen a bunch of these, but to be really strict, I should open up an existing header like vector or bitset or something and verify that they correspond so we're not forgetting anything. I happen to know the incantations pretty well, so I can notice any divergence. So we've got the pragma ones, which is not super necessary right now, but we continue to have it. Our guard macro, if and def under sync stream under. Yep, that's the right format. I'm going to check at the bottom that we have a comment corresponding to that. Yep, good. Okay, that looks good. Then at the top, we include yvals our central internal header for stuff that needs runtime support, like iostreams does. So that's good. It's not what we call a core header. If we are being built by an actual preprocessor, and if we're not in 20 mode, we complain the contents of sync stream properly replaced. It's good, or available only with 20 or later. Perfect. Otherwise, in 20 mode will actually do work. We're going to need memory. Not sure why yet. Mandated to include OStream. We need shared mutex. That's what we're working on here. And then stream buff. Okay, that looks good. We push the packing, push the warning level, disable things. Apparently there's a library, I want to say it was Qt, but I'm not sure, that was macroizing emit, which is extremely bad, and they should not do that, but technically they were there first, and then the committee added emit, regardless of the macro. So for practicality, we're going to push the emit macro and undef it so we can tolerate it, so that's good. And then it's undefed at the bottom in reverse order. Okay, that all looks good. Yeah, macros are evil. Okay, so we're within stood. Okay, so these are the separately compiled functions being added. Let's see, these are being declared as extern C STL. I think that's fine. We do have some separately compiled functions that are stood call when they're in the import lib. I'm not actually 100% sure which is better or more conventional. I think stood call is theoretically more efficient. That's what we were doing in file system, but I'm not 100% sure about our precedent here. I think CDECL is okay. I wonder if I should add a comment here. See, Casey, you're on the call. The what do you think? Should we? Because I know you added you've added like satellite DLLs a bunch before. Should we ask for std call here?
All right, you caught me completely not paying attention.
Yeah, so sorry to put you on the spot
Sorry.
here. I'm looking at these calling conventions. These are extern C functions being injected.
Oh, should we ask for std call? We kind of leaning towards std call, yes.
That was my sense. I wasn't sure how important it was. I did a lot of my separately compiled.
Yeah.
Okay, I did a lot of my separately compiled work in the older era where we only used like CDECL, but so for me, std call is new. Yeah.
Std call because std call has the callee pop, and therefore you get that instruction generated in one place in the called function instead of at every call site. So it saves a teeny little bit of code space.
Okay, that's what I vaguely remembered. Okay, cool. Thanks for your modern guidance. Although we have a bunch of old code using the CDECL calling convention, our new code prefers std call for a slight improvement in code gen. The definitions should be changed accordingly. This is the sort of thing where we got to get it right the first time because changing it later would be an ABI/mingle, or here it's not mingle name, but it would be an ABI issue if the declarations thought it should be CDECL and the definitions thought it should be std call. So we should definitely get that right. Okay. Okay, the next thing that I notice is that these two are no except, this one is not. But if acquiring a mutex tries to throw an exception through an extern C function, and the user has compiled with EHSC, which is my favorite compiler option, that tells the compiler, hey, assume that extern C functions cannot throw exceptions, that it will get a no except essentially implicitly applied, and the program will terminate. So it seems like this is problematic. Either it should be marked no except, or it needs to be marked as like no except false or something, so it opts out and can throw an exception, or it should report errors through some other mechanism. It seems like acquiring a mutex really should not throw. I think none of the standard mutexes do. So we should mention something here. The EHSC compiler option instructs the compiler to assume that extern C functions can't emit exceptions. Therefore, it seems I'm not sure whether we need to, instead of handle, I'm going to say deal with mutex acquisition, throwing exceptions. If shared mutex doesn't emit exceptions, then this, and I think, could be marked as, I need to qualify any assertions because I'm not 100% sure. If we do need to deal with exceptions, then we need to think about ways to avoid having EHSC interfere with this. Okay. The EHSC compiler option instructs the compiler to assume that extern C functions can't emit exceptions. I'm not sure whether we need to deal with mutex acquisition throwing exceptions. If shared mutex doesn't emit exceptions, then I think this should be marked as no except. If we do need to deal with exceptions, we need to think about ways to avoid having EHSC interfere with this. Also affects the definition. So yeah, here's a case where just looking for consistency among the markings qualifiers here is useful, combined with background knowledge with extern C and EHSC. Okay. Last thing, I'm running through my mental list of all the various things that we can add to function declarations. These two return void. This one returns a pointer, but it seems like ideally this should be marked as no discard, which we're now trying to use on internal helpers, because why would you try to get a mutex and then drop it on the floor? Let's see. I believe this should be marked as no discard. Okay. No discard is our favorite. Okay, these are properly ugly. That looks good. Okay. So now we have a class template. Basic. Okay, there's a mismatch here. This is actually basic sync buff impl, not osync buff impl. Yeah. Template on element traits. The class derives publicly from basic stream buff element traits. Okay. It has a member function. This is the one that's exposed to users, so that's why it is not ugly. Case constable valves, no accept, sets a mid on sync. This is the bool that it's managing. Okay, let's check the standard for mid on sync. Yep, here it is. Okay, it is mandated no accept in the standard. Okay, good. We got a virtual bool that is pure. Okay, so this is interesting. The first thing I think of is virtuals are another case where when we ship them, we lock down the ABI and we can't mess with them later. One of the things that we have wished we could change on some virtuals is their no accept attribute. In a lot of cases for internal functions, we don't need to be especially diligent about marking helper functions as no accept because the compiler has access to the implementation of header-only functions and can see, oh, you know, even if I'm not actually going to inline this thing, I can see the definition and it can't possibly emit exceptions. It's just, you know, modifying integers. So I don't need to add any EH cleanup logic. But if anything is separately compiled and we don't use link-time code gen, or if we go through a layer of virtuals, then the compiler can't know which actual, you know, overrider is being called. And so it could spend the effort to have EH cleanup code gen, even if we don't actually ever emit exceptions. So separately compiled and virtual functions are two of the cases where being diligent about no accept ahead of time can pay off. So here I need to see if emit can throw. I think it probably can because that implementation is complicated, but let's see what it does. So where was that emit? It was up here. Okay, so the fact that it's not no accept in the standard seems like, oh yeah, it's calling pub sync. The user could have called dot exceptions to say, hey, throw an exception when bad bit is set. Yeah, I don't need to look too deeply into this. This can throw. Okay, so it's correct to not have the virtual marked as no accept. Okay, so there's our do emit. Public looks good. I don't really think we need to mark this as no discard, even though it is internal. Okay, so protected using my stream buff is basic stream buff. That's the base class. We use the qualifier exactly once. It's fine. We default the default constructor. The move constructor. Okay, so this is a little strange. We go through default construction, or we use these data member initializers. We set these things to false, and then the move constructor we'll call swap to swap the values there, and swap the stream buff to acquire anything in there. That seems reasonable. Sometimes it's weird to implement a move constructor with swap, but this seems fine. Then when you actually swap, it is, that's interesting. So is swap marked as no accept in the standard? see where non-member swap is no except. Ah, member swap is no except. Okay. Oh, but this is on the base class. So it's not virtual. It doesn't really need to be no except. I'm going to just scroll down a bit to see if swap. Okay, swap is no except on the standard. That's interesting. This doesn't. Oh, swap except L probably calls the base class. Or not? Where is this coming from? Overflow. Swap except L. Okay, it does call my base swap. Okay, so here we have a case where the derived function is marked as no except. It calls a base class function that is not marked as no except. But that is fine in CodeGen terms because it's not virtual. The implementation is available. It does seem morally like a swap should be marked as no except, even if it's not required. I think I'll comment it here. Although it's not necessary, as this, and technically we do have a, well, that's actually interesting. This is being, I'm running like through like how this is visible to users. Let me cancel this comment. We've got this basic sync buff impl, which is a base class of the basic sync buff. It's exposing a non-ugly name swap that swaps with the wrong type in some sense. And then that gets shadowed with, or shadowed by, where is it? I should say hidden by the derived swap, which I have scrolled over. Where is it? Yeah, this one. So it gets hidden by this. That's a little weird. We will name internal functions as non-ugly when they're directly visible to users, like in the case of the, where was it? Set of mid on sync. But in this case, this really only exists for STL internal usage. It is, I find it somewhat confusing to use the standard name when it's not actually implementing standard swap, and it is protected here so that the derived class can access it. I think I'm going to recommend naming this something else, like ugly base swap or something, and mark as no except. So let's get the right name here. Basic sync buff impl swap is hidden by basic sync buff swap. And used within its implementation. Although this is correct, I find it slightly confusing. Generally, when a base class provides non-ugly names, they're visible to users, as is the case for set emit on sync. As is the case for set emit on sync above. Here, this is implementation internal. So I recommend using an ugly name like base swap or something, doesn't really matter. Or swap base or like. Additionally, I recommend marking this as no except for clarity, since the derived classes swap must be no except. Although there should be no code gen impact because the compiler can see this definition. It helps human readers understand. So right now, all the programmers are human for the time being. Okay, basic sync buff impl swap is hidden by basic sync buff swap and is used within its implementation. Although this is correct, I find it slightly confusing. Generally, when a base class provides non-ugly names, they're visible to users, as is the case for sediment on sync above. Here, this is implementation internal, so I recommend using an ugly name like base swap or swap base or anything you like. Additionally, I recommend marking this as no except for clarity, since derived class of swap must be no except, although there should be no code gen impact because the compiler can see this definition and helps human readers understand. Okay, so then that calls swap on my stream buff, which is a public name, so that's why it's named swap. And then std swap on these two bools. Okay, looks good. Data member initializers. Okay, class template basic sync buff. Derives from the basic sync buff impl. This actually doesn't need to be public as far as I know. No, sorry. Yeah, we need to have the set emit on sync. So yeah, we could probably have a private base class and then drag this name in as public, but I think there's no harm. Oh, and we actually need the basic stream buff. Okay, so public is right. I love that inheritance. I sometimes forget how like virtual inheritance works because we don't really use it in the rest of the STL. So whenever we move to or work on PRs in IO streams land, I have to sort of reload all that standard using my head. Okay, so we drag in some type defs. I should probably be verifying against the standard here. Let's go up to the basic sync buff. Okay, so we derive from the stream buff with the additional layer in there. We've already got these default template arguments provided by iOS forward. So this should have char type, int pos off, traits, and allocator. Okay, int pos off, and then the char traits allocator. So we got int pos off. Where's char type? Where's traits type? We seem to be missing type defs. Yeah, I don't see any down here. Okay. I don't believe these are provided by base classes. Not here. Question is, what is basic stream? What was it? Stream buff. Sorry, I'm scrolling over. Basic stream buff provide. This grabs traits. I don't think these are being provided by a base class. Let me see what the standard says. It's probably easier. Let's navigate to stream buffers. Basic stream buff. Okay. Basic stream buff provides traits type and char type as char t and traits respectively. And although, but wait, it's within this class. Unqualified name lookup does not reach into dependent bases. That's a rule related to two-phase name lookup. But as far as external users are concerned, it is a name provided by the base class. So I think we're okay getting char type and traits type from the base class. Trying to think, should we have like a using there? Guess a question for precedent would be, what does basic string buff do? This has the same system where it's got the char type and the traits type. Let's take a quick look at what stream does. I think it's an stream and not string buff. Let's see. Stream. Okay, so you got your basic string buff, which this I suspect was could have been used as a copy paste precedent. Okay, so this has got the same technique. It only provides type defs that are not already provided by the base class. Okay, and anything that the class itself needs, because the unqualified lookup issue. So this is fine. Okay, so we can rely on, let's look at that string buff. Char type and traits type coming from the base class. So it's in pause off that I think this thing itself needs, and the allocator type. Okay, in pause off allocator type. Okay, that's good. Where is this coming from? Oh, this one here. Okay. Yeah, char trait. So in pause off allocator string buff. In pause off allocator string buff. Okay, so these are all standard. Good. It's very easy to have a non-standard type def that looks vaguely plausible. So that's why I like to double check. So grab the in type, the pause type, and the off type. Copy paste errors there. The allocator type is specific to us. The string buff type is our double base class. My base is the immediate base class. It's interesting. I'm wondering, where do we use my base? Oh, it's used right there. Awesome. Pointer, we grab the pointer type def from allocator traits and size type. Double check where these are coming from. Oh, hello. That's not. Okay, I think this is a bug. So basic sync buff is depicted as only having these type defs. And then a bunch of constructors, member functions, and that's it. It should have no other type defs, and the presence of non-ugly type defs is detectable through SFINE. And I believe that pointer and size type here, I'm going to open up an editor so I can do some bookkeeping. Okay, so we verified that it was the char type and traits type that come from the base class. Yep. So there we go. The char type and the traits type are from the base class. In pause off are being defined here because presumably we need them below, so it's okay to have that. We got the allocator type, we got the string buff type. My base is internal, but these pointer and size type are not depicted. So I believe this is a bug. If we do need to use them, at a minimum, they should be private. And if they're private, then SFINE will detect that they're not accessible. Or they should be ugly, but it's okay to have a private non-ugly type def. We do that for pointer like everywhere, and size type is common enough. We know it's not going to be macroized or anything. So here I need to comment. These, I'll say, in case I'm wrong, as far as I can tell, pointer and size type aren't depicted as public member types of basic sync buff. If the implementation needs these, they should be private. Although we commonly uglify internal type defs, we widely use pointer and the and it should be okay. Do the same for size type. We don't need to worry about macros. We just need to ensure that users can't detect basic sync buff, pointer, etc. through SFINE. As far as I can tell, pointer and size type aren't depicted as public member types of basic sync buff. If the implementation needs these, they should be private. Although we commonly uglify internal type defs, we widely use pointer It should be okay to do the same for size type. We don't need to worry about macros. We just need to ensure that users can't detect basic syncbuff pointer, etc. through Sphene. Trying to think, if a user derived from this class, would that also cause trouble? I don't think so. I think it should be fine to just make them private. Instead of uglifying. Okay. So this has a using declaration for my base set of mid on sync. Drag that in from the base class. Okay, let's go back to the standards. Okay, so we've got all of our type defs. Okay, so this is depicted as having a pointer to streamBuff type wrapped. Okay, that's the basic streamBuff there. And then the set of mid on sync is managed by the base class, the helper base class. So we've got a default constructor that delegates, delegating constructor, to using null putter there. That delegates to using a default constructed allocator, and then that's implemented below. Move constructor to destructor. Okay. So this has a defaulted default constructor. Does this have a data member initializer somewhere? It does. Wrapped is null putter. Al is brace brace. Okay, so that's good. Not going to be garbage or anything. Okay, we've got, is that supposed to be explicit? Yes, explicit from streamBuff type star obuff. Good. Here it's called stirbuff. That's great. This is so small, it really doesn't make sense to ask for like top level const here, so I'll live with that. So pass that or delegate to the other constructor with alloc brace brace. That should be fine for code gen performance. We found in other cases that implementing things with delegating constructors can be not quite optimal, but really the only class where we've worried about that extensively is vector, because vector is so important for performance. Here, basic sync buff, it's fine. It would be more obnoxious to like duplicate this implementation. Okay, now explicit constructor, taking stirbuff and underscore al underscore to avoid shadowing. That's perfect. If we have a wrapped pointer here, then call acquire mutex for instance. Okay, and then call init, and we'll see what that does. Okay, we've got the move constructor, which moves the allocator and then swap except al, because it's not supposed to do any sort of Pokemon, I'm guessing. Yeah, certainly move constructor should not. Let's look at what this says. So it's wrapped obuff. Okay. Then the move constructor. Okay. It dissociates other from its wrap stream buffer, ensuring destruction of other produces no output. Okay, so that's what the swap except al should do. Okay. The DDoR will emit and tidy. Okay. Got a move assignment operator. And Mbusio is saying that it's required by the standard to be no except. That's weird. Why doesn't the standard require the move CDOR to be no except? Did we miss that? No. It's not required to be no except. There's no except here. What's going on? Whoa. The class definition differs from the declaration. Or the function definition. That is a defect, editorial issue in the standard. Yeah, there's no except here, and also not on the move CDOR. The definition of the move CDOR doesn't have anything, but the definition here does. Okay, so that's an editorial issue. So Adam Busier is correct that there should be no except. Oh, okay, and that's reading comprehension STL. That's exactly what Michael Riscala says. And move assign with no propagate allocators could call allocate, which might throw. Okay, so that's interesting. Either the standard is certainly wrong in some sense. Either the class definition needs to say no except, or there should be no except on the definition. If This is correct, which seems compelling. So what does the definition do? Calls emit, and we've seen that emit, like we believed it could throw exceptions. This is when I was looking at the virtual, because it calls all those virtuals. It seems highly suspicious that this is marked no except. Yeah, what does move assign do? Move assign says move assign just sorry, no propagate. If the allocators aren't equal, you tidy. Oh yeah, you allocate. Yeah, that can allocate memory. So slamming in a no except seems super wrong. So I think this is a defect. Yeah. Yeah, this looks like it should be reported as an LWG issue and no except appears to be incorrect in the standard. Okay. Okay, so this, let's see. I've got a hard stop at 5:30, so we got about maybe 10 more minutes of reviewing. Then I'll submit a partial review. We've got, if there's any questions, feel free to jump in. So this should emit and then move assign from right-hand side. So right-hand side should have null putter for the wrap stream buff. The allocator should be equal when Pokemon is true. Otherwise, the allocator is unchanged. Okay. So they don't necessarily have to be equal. Okay, so emit if the addresses of these buffers are different, then do a move assign and then return DRF this. Okay. This is using tag dispatch. We can use if context for now, although choose Pokemon is like pretty complicated. It's got like these 3 different modes. So this is the current pattern, so using that is good for consistency. Okay. We swap with the basic string buff. This is required to be no except in the standard. We saw if we are different objects, we should propagate on container swap. Is that mandated by the standard? That's interesting. There's a precondition here. Either we need pokes or the allocators need to be equal. And there's no verification here. We have traditionally had an STL cert, I believe, that will complain when an allocator does not set propagate on container swap pokes and the allocators are not equal. Here, this just tries to propagate and then swap. It seems like we should have an assertion. That is sync buff assign 5. Actually, I can. This is a quote, block quote. It's an italic. Either allocator, I can use control. Allocator value is true. Oh, I don't want to skip past the space when I use control. Or this is true. Okay. I believe that in swaps, we conventionally assert for mismatched allocators, enforcing the precondition in this.
Oh, Stefan?
Yep.
Pox does that.
Oh, Pox does that internally. Oh,
Yeah,
awesome.
yeah, Pox does that internally. I was just
Oh,
sitting here
great.
thinking, why don't we put that in Pox? Pox should do that. And I went and looked,
Yeah.
and it already does. So
Wow.
yeah.
These STL maintainers that make these, helper functions are so useful. Okay, great. Go historical us.
Thank you, Billy.
Yeah. I remember I made the Pox function, but I think I didn't assert there. So
Yeah,
I'm
I
guessing
think
Billy
that
had
was a
edited.
change he did.
Okay. I remember the code I wrote. I don't remember the code of the Okay, that is great. Reduced opportunities to get things wrong and increased centralization. Okay, so then emit, I think this can be the last function we look at. It's a big function. Atomically transfers the associated output of this to the stream buffer wrapped. So it appears in the output stream as a contiguous sequence of characters. This does the actual work. Pubsync is called if and only if a call was made to sync since the most recent call to emit, if any. I wish I understood the IOStream sync and pubsync convention. On success, the associated output is empty. It sort of emits everything that it's stored up since the last printing. Returns true if everything holds, otherwise false. So wrap output is false. Everything is transferred, and the call to pubsync is, or this double negation is annoying, that we have a wrapped, everything was transferred, and pubsync succeeded. Synchronization, it's got to be total ordering, and can call member functions a wrap while holding a lock uniquely associated with wrapped. Okay, that'll be handled, I believe, by the separately compiled code. Okay, so wow, look at what claim format did. Okay, boolmit. If we don't have a wrapped pointer, then return false. Okay, full result is true. We got a const size type data size, get data size, begin seek footer, tuple of a const pointer to lm. Call in the stream buff type pbase. Okay. If the data size is greater than 0 or my base, we can access the single quoted bool. We have a scope block guard. This is being constructed with parentheses. This is using CTAD, which is good. Kind of wondering if we should use braces there, but I guess parentheses are okay. It is clearly a named variable. It's not a temporary. Deref get mutex for instance. Okay, so this calls that separately compiled function. Later, I'll go back and see if I can understand exactly what this code is doing here. I'm just trying to get the high level picture. I'm seeing if I can notice any like oversights or things that don't make sense according to our conventions. Okay, so here we don't know for sure if data size is greater 0 because it could have been single quoted. But if data size is greater 0 and the data size is different than is put in, okay. This is signed long, so that's okay. Set result false. Okay, and then if my base sync recorded was true, if pubsync's -1 false, okay. Set sync recorded to false. Call set p, reset written data. Okay, that seems reasonable. And I guess we can finish up by looking at these. These are just get functions, so they can be notice guard. That's good. Okay. Okay, got up to the end of the public member functions here. I will submit a partial review. Comment as a note to self, reviewed up to here, because GitHub does not have a sub-file viewed state. There we go. Partial review, looked at up to single. Line number may change, but I'll leave that like that. Okay. I'll just submit comments for now rather than changes requested, even though I think I did see some things that needed addressing. Go GitHub, go. Yes. Submitted successfully. Okay, found some good issues, some minor cosmetic things, and double checked that Adam and Michael had found a standard defect, even after all the patches it's received. So a good day. Okay, I think we can call that a video review. Are there any questions for all the stuff that we went through, or any related topics that come to people's minds? Doesn't sound like any. So thanks, everyone.
All right, I will stop the recording, and we'll see you all